So in this tutorial we're going to take a look at unit testing with Mocha and Chai, and this tutorial is really for anyone who's never written a unit test before, so we're going to cover the basics of why you would unit test and then how you would do that with the Mocha and Chai libraries. And we're using these rather than another framework like Jest or Cypress, simply because the syntax is quite easy to understand, and there are a lot of organisations that will be using Mocha and Chai as their testing framework. So it's good that you're acquainted with them, so if you do take on a role where they're in use, you'll have a good grasp of how they work. So there's a link for the code for this video in the description below if you want to follow along, and let's start writing our first unit tests with Mocha and Chai. So in order to understand unit testing with Mocha and Chai, we're going to set up a small project that has a few functions, and then we're going to write some unit tests for them. So the first thing we'll do, if we head over to our package.json file, you'll see we have no dependencies currently for this project. So let's install the necessary dependencies that we're going to be using, which is Mocha, Chai, and Nice. So we can simply write npm install and then use the save dev flag because we're going to save these as dev dependencies, and then Mocha, Chai, and Nice. So that might take a minute or two to install, but you can see the dev dependencies are now listed in our package.json file. So let's quickly run through what each of these packages will do for us in this tutorial. So Mocha is the test runner, so we use this to issue the commands to run the tests that we're going to be creating. And Chai is an additional assertion library, which works well with Mocha and they're commonly used together. And you'll see in a moment how that provides a bit more flexibility when we're writing our test cases. And Nice is a code coverage generator, which will show us visually how much of our code has been covered by our unit tests. So we're going to be writing our tests in a separate folder called tests, so let's create that now. And then we can actually update our script section in our package.json file here. You see at the moment the script to run our tests won't do anything, but we can replace that with a call to Mocha by just simply saying Mocha test, where test is the folder that's going to be holding all of our unit tests. So if we go ahead and test that out now by simply saying npm run test, you'll see the script runs, but however, there are no test files at the moment, so we get this error saying that no test files are found. So let's go ahead and create a test file now. So in our test folder, let's create a new file and we'll just call it app.spec.js. So we give our test files a name that correspond to the actual source file that we're going to be testing. So in this case, we simply have the app.js file in our source folder. So we name our test file app, and the .spec extension is optional, but it'll just let other users know that this is a test file. So if we go ahead and run Mocha again, you can see this time it passes, however we get a result of 0 passing tests because we haven't actually written any tests yet. So before we write our first unit test, we just need to import a few dependencies. So the first thing we're going to do is import assert, which you'll see in a moment we'll use to make assertions about our test cases. And the other thing we're going to need to do is import the function from our app.js file, which if you look, we simply have one function at the moment in there called add, which takes 2 arguments and adds them together. So in our app.spec.js file, we can simply get the add function from the app.js file by referencing its path in the source folder. So now we're ready to write our first unit test, and we can write our unit tests with 2 functions, the describe and the it function. So you can think of the describe function as testing one specific function or a group of related functions, and the it function creates a specific unit test, which is testing part of the logic inside of that function. So I'm going to use the describe function to create a block of unit tests for the add function that we're importing from our app.js file. So we'll say describe. And the text in here can be anything that you like. I'm going to describe the add function. And then the second argument for the describe function is actually a function itself. So I'm just going to put an empty arrow function in there. The Mocha documentation does discourage using arrow functions for various reasons, but for our purposes in this video, it won't cause a problem. So inside here, we're going to create an it function, and this is going to be the specific test that we're creating, which is testing a part of the function. So we'll say function, the add function should add 2 numbers together, because that's the purpose of the function. And again, we can pass another anonymous function into the second argument of the it function itself. And here we need to write a test which will test the functionality of the add function. So because we've imported it here on line 2, we can just call the add function by its name anywhere in this code. So let's call it and save the result into a variable. So we'll say const result is equal to add 2 and 2. So if we're adding 2 and 2 together, we should expect the result to be 4. So we need to tell our unit test that that's what we're expecting for the result from the add function. So we can do that by using the assert object that we imported on line 1. and we can say assert. We want to say that we want to test for equality and the results that we got from our add function, we want to say that's equal to 4. So the equal function on the assert object will take 2 arguments, and it will check both of those arguments to see if they're exactly equal. So if we run those tests again with our npm run test script, you can see in the terminal that we're running one test, and you can see it says the add function should add 2 numbers together as we wrote in our describe and it functions. And you can see we've got a green tick because the result from the add function was equal to 4. So if we change the assertion and say that we're actually expecting the result to be 5, for example, and then run that test again, you can see that that test fails because we were expecting the result to be 5, but the actual result from the add function was 4. So this is the basis of all unit tests. You're going to run a function or run some code that you've imported from your main source, and then you're going to check that the result that you're expecting actually matches the result that the function produces. So where does the Chai library come into all of this? Well, if we look at the assert object that we've imported, you'll see there's various different functions on here to check the result from our add function. We can say that it's not equal to, or check its length, for example. So there are a lot of different functions which will allow us to control the assertion that we're making. So let's actually import the Chai library. And there's actually one function that we want to import on there called expect. So we can destructure that from the Chai library. And if we look down here now in our unit test, if we make a call to our expect function and we pass in the result, and then if we look at the properties and functions that we've got available on our expect function, you can see there's quite a few more different types of assertions that we can make, providing greater flexibility in the kind of assertions that we can write. And also the assertions that you make tend to read a little bit more like English than just using the assert object. So for example, if we wanted to recreate what we had before, we're saying we expect the result, and then we can say to be equal to 4. So if we save that and run the tests again, you can see our tests are now passing again, and we've rewritten our first unit test using the Chai assertion library. So you might be thinking, well, this is pretty obvious, like obviously adding 2 numbers together will give you the result of 4. Do we really not need to write some code that will actually check that for us? But where unit testing becomes really interesting and really useful is when you start thinking about all the types of ways that you can use the specific functions that you're testing, like the add function in this example, and seeing how it behaves when you pass in various types of data. So for example, with our add function, it accepts 2 arguments, but what happens if we actually miss out one of those arguments? Does it behave in the way we'd expect it to? So let's write another unit test for that. We should say it should be able to handle 1 number. So for our result this time, we'll say our result is equal to add, and then we'll just pass in a value of 2. So there we've got only 1 argument passed to the add function. And then we'll use our Chai expect function to say we expect the result to be equal to 2, which is a fairly reasonable assumption. If we're only passing in the value of 2, we should expect the result to be 2. And if we run our unit tests again, you'll see the second test actually fails. So here you can see we're expecting the result to be 2, but the actual value that we got out was not a number. And that's because in our function of add, we should find that the number of 2 gets populated into the a variable, but the second argument b will be undefined. And so if we try and add 2 and undefined together, we get not a number. So how do we make this unit test pass? Well, we actually need to update our add function because it's not behaving as it should do. So one solution would maybe to provide default values to a and b so that we don't get that undefined value if the user forgets to pass in 2 arguments. So we'll say a is equal to 0 and also b is equal to 0. So if we don't pass in an argument for one of those now, they will default to the value of 0. So if we run our unit test again, you can see that second unit test is now passing. So that's just a small example of how you would use a unit test to actually improve the code that you've written. Let's go ahead and write a couple more. So it should be able to handle 0 numbers as well. So if the user passes in undefined, or those values get lost at any point when we try and call the add function. So let's say const result is equal to add without any arguments. And because those have been defaulted to 0 for both a and b in the add function, we should expect the result to be equal to 0. And let's run our tests. And there you can see the third test is passing as well. So you might think our add function is pretty robust now, but what about if we actually pass in other values that aren't numbers? So for example, if the add function gets accidentally called with a string. So obviously strings added to numbers won't produce a very useful number, so we should probably return like a default value like 0 if we try and add a string to a number. So let's write a unit test for that. We'll say it should return 0 if either argument is not a number. And let's open up our function here. So let's recreate that. We'll say the result is equal to add, and say if we try to add to the word test. So let's say we'll expect the result to be equal to 0. So if we run those tests at the moment, currently we won't get that result. You can see the result we actually got was 2 test because the number 2 got changed to a string and then added to the test string. So we need to update our add function to handle non-numbers. So one thing we could do in here is if we open this up, and we could do a check in here to see if the arguments that have been passed in are indeed numbers. So we could say if type of A is equal to number, or we probably should say not equal to number, or type of B is not equal to number, then what we can do is we can return 0. But if that's all good, then we'll just return A and B. So this way we're checking our arguments to see if they're actually numbers, and if either one of them isn't, we'll actually just return 0. So let's run our tests again. So you can see now the 4th test is actually passing, as the add function is now returning a 0. So if you want a little bit of practice at this point, what you could do is create another function called sub or subtract, and it'll do the opposite thing of add and taking 2 arguments and subtracting one from the other, and see if you can write that function and then write the unit tests for it, and see if you can think of all the expectations that might come out of that function, and then use your unit tests to expect those results, and then check them by running the tests. So if you had a go at this exercise, you might have ended up with something like this. It's essentially just a copy and paste job from the add function, and it's exactly the same function except on the last line we're actually just returning A minus B. And the unit tests themselves, we can pretty much recreate what we had for the add function. So we have the same things where we should be able to sub 2 numbers together and get a result, should be able to handle 1 number, 0 numbers, and also if there is a non-number provided as an argument. So if we go ahead and run those unit tests again, you can see we actually get a failure, and that's because in the sub function, when we're handling just 1 number, the first argument will actually get populated with 2, and then if there isn't another argument, that will default to 0, so we'll be actually subtracting 0 from that. So you can see the expectation that we might get minus 2 is actually incorrect, so we can just update that and say we're expecting the result to equal 2. And you can see how that unit test was really useful. I was making a specific assumption about that function that it would return minus 2, but the actual result was different. So I can either update my unit test with the correct assertion, or maybe I would go back into the app.js code and update the sub function. So we also installed the nice library when we set up our project, and the nice library allows us to have visual code coverage of what functions within our code we've actually written unit tests for. So to run nice, I'm going to create a new script. So I'm going to go to package.json, and I'm going to call the script coverage, but you can call it anything you like. And we're going to run nice, and then the command I'm going to run is npm test. So if we run npm run coverage, you can see Mocha runs again and runs all of our unit tests, but this time we get some output at the bottom from nice that tells us what our coverage levels are. So you can see in our app.js file we're covering all of our statements, branches, functions and lines, which isn't surprising as our functions are fairly simple and we've written a decent amount of unit tests to cover all the different use cases. Another option with nice is to create a HTML output that you can view in the browser. So when we run nice, if we pass an option of reporter and set that value to HTML, if we run our coverage again, you can see we don't get that output at the bottom of the terminal, but we've created a new folder called coverage, which has in it all our coverage in HTML format. And if we just open up the index.html file, you can see we have a nice web page that has all of our source files. In this case, it's just app.js. And if we click on there, you can see the functions that we've created, and you can see the coverage levels for each of those functions. So for example, if we were to get rid of the unit tests for the sub function, and rerun our coverage again. If we go back to the HTML output, you can see our coverage has dropped, and also nice is highlighting to us the functions and lines of code which we haven't written unit tests for, which is really useful if you're working on a larger project and you're not sure which functions and parts of your code have actually been covered. So that's just a quick introduction to unit testing with Mocha and Chai. Hopefully you've seen the power of unit testing and how you can see that a simple function like adding two numbers together requires a little bit more thought when you're actually going to be using it in a real project. Of course, when you're writing more complicated functions, then you need to think of all the types of input the function can receive and all the different types of behavior it can have, and write a unit test for each of those cases. So that's it for this tutorial. There'll be a second part to this where we'll actually cover more in-depth unit testing when you've got more complicated code that's asynchronous, for example, and we'll look at some of the libraries that you can use in conjunction with Mocha and Chai in order to create more effective unit tests.